Hello friends, I welcome you in lecture number 3 on wave equation. In this lecture also we will discuss one question on wave equation which was asked in GTU Winter 2019 exam. Here the question is, a string of length L equal to pi has its ends fixed at x equal to 0 and x equal to pi. Here it is given that they are considering a string of length L equal to pi and it is fixed between two ends 0 and pi. That is, string is fixed between these two ends. That means there is no displacement of the string at these two fixed points. That is, deflection u0t equal to 0, and at x equal to pi also displacement or deflection of the string is 0. At time t equal to 0, the string is given by a shape defined by fx equal to 50 times x into pi minus x. They are giving the string the shape defined by this function, that is the motion of the string at t equal to 0, that is displacement of the string at time t equal to 0 is given by this function fx 50x times pi minus x. That means at time t equal to 0, the shape of the string will look like the graph of this function 50x times pi minus x, and then it is released. And here we have to decide the deflection of the string at any time t. We are given the deflection or displacement of the string at time t equal to 0, which is 50x times pi minus x. We are also given that string is having its ends fixed at x equal to 0 and at x equal to pi. That is, at these two end points there is no deflection, that is u0t equal to 0, u pi t equal to 0, and they have nothing given about velocity. So we assume that velocity is 0 at time t equal to 0, that is del u by del t at time t equal to 0 is 0. We can see that at time t equal to 0, string is given a shape defined by this. So before this we can assume that there is no velocity given, and therefore at time t equal to 0 we consider velocity equal to 0 and we denote velocity function by g of x. So in this problem we are given this string of length L equal to pi, which is satisfying these two boundary conditions and these two initial conditions, and using this information we have to decide the deflection of string at any time t. That is, we have to find out the function of space variable x and time t that we want to decide. And as we have discussed that these vibrations of string are governed by the one-dimensional wave equation given by del square u by del t square equal to c square times del square u by del x square, and here the length of the string is pi, so we write that x lies between 0 and pi and t takes non-negative values. We are also given the boundary conditions that string is fixed at end points, that is, when x equal to 0 there is no deflection, when x equal to pi there is no deflection, and this is for all values of x between 0 and pi. We are also given that at time t equal to 0 the deflection of the string is fx, and that fx is given as 50 times x times pi minus x, and this is for all values of x between 0 and pi. And we are also assuming that there is no velocity at time t equal to 0, that means u del u by del t at t equal to 0 is 0, and we consider this as gx, and x lies between 0 and pi. This is given information, and we have to determine the function of x and t, which is deflection of the string at any time t, which satisfies this wave equation as well as these two boundary conditions and these two initial conditions. And if you recall, in lecture number 1 we have discussed the formula for the solution of wave equation satisfying this type of boundary and initial conditions, and we know that the formula is uxt equal to sigma n equal to 1 to infinity bn times cosine of lambda n t plus bn star times sine lambda n t. This we write in the bracket. This is multiplied with sine n pi x over L, where L is the length of the string. This lambda n is nothing but Cn pi divided by L, n equal to 1, 2, 3 and so on. And what was the formula for Bn? Bn is given by 2 divided by L integral 0 to L fx times sin n pi x by L integral with respect to x, and for all n equal to 1, 2, 3 and so on. And Bn star is equal to 2 divided by Cn pi integral from 0 to L gx multiplied with sin n pi x over L integral with respect to x, n equal to 1, 2, 3 and so on. So this we have to remember, and it is easy to remember this formula for the solution of one-dimensional wave equation satisfying this type of boundary and initial conditions. Now here we find that length of the string is L equal to pi and value of gx function is 0 and fx is 50 into x into pi minus x. Now because gx is 0, this bn star is going to be 0, and all we have to decide is value of bn, and if bn star is 0, our solution will be bn cos lambda n t into sin n pi x over L, and lambda n is Cn pi over L. So we can write first what is lambda n. It is C into n into pi divided by L, but here L is given to be pi, therefore lambda n is going to be C times n, n equal to 1, 2, 3 and so on. This is lambda n. Now we find out Bn. For Bn we find that fx is given by, they have given the initial deflection by 50x times pi minus x. So I am writing fx here 50x times pi minus x, or this I can rewrite as 50 times pi into x minus, I multiply this by x minus x square. So now we write down the formula for Bn. Bn is 2 divided by L integral from 0 to L f of x times sin n pi x over L integral with respect to x, and here L is pi, length of the string is given as pi, so we put L equal to pi. Fx is 50 times pi x minus x square, 50 times pi into x minus x square. Let me check properly. 50 times pi into x minus x square. If we take L equal to pi here, this pi will get cancelled and we are left with sin nx integral with respect to x. And now I can take this 50 outside integral, and 2 into 50 is 100 over pi. We write one more step, 0 to pi, pi x minus x square times sin nx integration with respect to x. Now here we see that we have product of two functions, pi x minus x square and sin nx, and we use integration by parts to find out the value of this integral. We consider u as pi x minus x square and v equal to sin nx. And if we recall the formula for integration by parts, we know that general formula for integration by parts is u as it is integral of v, that we denote by v1, minus derivative of u, which is denoted by u dash, integral of v1, that we denote by v2, and then alternately positive and negative sign. So if there is negative sign here, I will write plus, then I differentiate u dash, that I write as u double dash, I integrate v2, that I write as v3, and we continue in this way. And we select that function as u whose derivative is 0 after some finite number of steps. Here we consider u equal to pi x minus x square because derivative of this function will be 0 after some finite number of steps, and we consider v equal to sin nx. So now I am using that formula for general rule of integration by parts. This is 100 over pi, and first I keep u as it is, that is pi x minus x square as it is. Integral of sin nx is minus cos nx divided by coefficient of x, which is n, minus derivative of this first bracket, which is pi x minus x square, that is pi minus 2x, into integration of second bracket, integral of cos nx is sin nx by n, and there is negative sign, and there is already one n present in the denominator, so that we will have n square, plus integral of derivative of this bracket, which is going to be minus 2, and integration of this bracket, integral of sine function is minus cos, so negative negative positive, we have to divide by n also, so there will be n cube here, and finally we have cos nx divided by n to the power 3, and we have to take limits as x equal to 0 to x equal to pi. This is by integration by parts. Now first we try to decide value of this whole bracket at x equal to pi. So if we put x equal to pi, we find that, suppose I take x equal to pi here, then I will have pi into pi minus pi square, that is pi square minus pi square. So this term will become 0 if I take x equal to pi, and it is in the product of this term. So this whole term is going to be 0 at x equal to pi. If I take x equal to pi here, I will have sin n pi, and n is positive integer, and we know that if n is integer, sin n pi is 0. So this is also going to be 0 at x equal to pi. If we take x equal to pi here I will have cos n pi minus 2 divided by n cube. So there will be only one non-zero term, that is minus 2 cosine of n pi divided by n cube. At x equal to pi, we have only this non-zero contribution. This is for x equal to pi. Now we think for x equal to 0, that is lower limit. So again we can see, if I take x equal to 0 here, this term will be equal to 0. Here also sin 0 is 0, so this is also going to be 0, and here we will have cosine of 0, that is 1. So here we are left with minus 2 divided by n cube when we put x equal to 0. Now this we can rewrite as 100 divided by pi. We know that cos n pi can be written as minus 1 to the power n. So this minus 2 upon n cube into cos n pi I am writing as minus 1 to the power n, and here I am left with 2 divided by n cube. Again I can take 2 divided by n cube common. So here I am writing 100 over pi 2 divided by n cube, and here I am writing 1, and here I am left with minus 1 raised to n. And finally we can rewrite this as 200 divided by n cube pi 1 minus 1 to the power n, and this is nothing but bn. N starts from 1, 2, 3 and so on. Now this minus 1 raised to n, this is going to be 1 if n is even. If n is even, then minus 1 raised to n is 1. So in that case all the coefficients bn will be 0. So we can say that bn will be 0 if n is even, and if n is odd, then this minus 1 raised to n is going to be minus 1, that is 2. So if n is odd, this quantity becomes 2, and 2 into 200, that is 400 divided by n cube pi. So we can again rewrite bn as, therefore, or we can write equal to 0 if n is even positive integer, and if n is odd, this is going to be 2, and 2 into 200, that is 400 divided by n cube into pi if n is odd. And of course here n is a natural number. Same thing here, n belongs to n, and n is odd and even. So this is our bn, and bn star will be 0 because we are given that initial velocity is 0, therefore function gx is 0. We are considering gx equal to 0, and we mentioned that bn star, we just write down the formula, 2 divided by cn pi integral from 0 to L gx sin n pi x over L dx, but gx is 0, that means bn star equal to 0. So we write that bn star equal to 0 for all natural numbers 1, 2, 3 and so on. So now we are able to write down the solution, or we can write that now the deflection of string at any time t, is, we first write down the formula. This we have to remember, uxt equal to sigma n equal to 1 to infinity. We have bn cosine lambda nt plus bn star sin lambda nt into sin n pi x over L. And we have all these things now that we substitute here. N equal to 1 to infinity, bn lambda n is nothing but c into n. We have written lambda n here. Lambda n is c times n, that we substitute here. Lambda n is cn into t. Bn star is 0, so there is no contribution from this term. Length of the string is pi, so this pi will get cancelled, and here we write sin nx. Now we know that this bn is 0 if n is even, so we write down only odd terms, or terms corresponding to the odd values of n. So we write for n equal to 1, we have b1 cosine of ct into sin x. We take everywhere in this n equal to 1. So b1 cos ct sin x. Then we take n equal to 3. So we have B3 cosine of n is 3, so 3 times ct sine 3x, plus we can write few terms, cosine of 5 ct into sine 5x for n equal to 5, and so on. Now what is Bn if n is odd? Bn is 400 divided by n cube pi. So for n equal to 1, we have 400 divided by 1 cube into pi. For n equal to 3, we have 400 divided by 3 cube into pi. For n equal to 5, we have 400 divided by 5 to the power 3 into pi. So we have this 400 over pi common in each term. So we write here that B1 is 400 divided by 1 cube into pi cos ct sin x plus 400 divided by 3 cube into pi cosine of 3 ct into sin 3x plus 400 divided by 5 to the power 3 into pi cosine of 5 ct into sin 5x, and so on. And we can take this 400 over pi common, and here we are left with cos ct into sin x plus cos 3 ct sin 3x divided by cube of 3 plus cosine of 5 ct into sin 5x divided by cube of 5, and so on. So this is the deflection of the string at any time t which is required for our problem. So in this way we can easily find out the solution of wave equation satisfying given boundary and initial conditions. All we have to remember is this formula which we have derived in lecture number 1, this formula as well as formulas for Bn and Bn star. So this is very easy question, and it was asked for 7 marks in GTU Winter 2019 exam. And we will continue with this type of GTU exam questions in upcoming lectures. Thanks for watching.